syntactically correct program does not mean it will give you the desired results, because it may be semantically incorrect or logically incorrect. These are the things. Formal syntax is a system for describing the structure of the program exactly, and such systems include the grammars, Backus node forms, syntactic diagrams, that means syntax graph, etc. We will see when we discuss about the syntax tree, we will see this thing in details. What is grammars? There are infinitely many defined programs, but every program is finite and must be recognized in finite time. And a grammar should allow a finite description of a usually infinite language. What is semantics? Semantics of a language determines the meaning of elementary units and their combinations. How does the meaning of a program derives from the meaning of its fragments? The effect of the compound statements such as loop or if should depend only on the effect of the elementary statements such as assignment. That means what is a semantics? Every production rules which are already we have seen, every production rules is associated with a meaning of these things. That means what is the interpretation of the production rules, and this is basically known as the semantics of the language. There are three approaches for the semantic description. That is operational semantics, simple lower level operations, how higher level statements are performed. Denotational semantics, that means program computes the functions, that is a mapping. There must be some rules of mapping there which can from data to results. And axiomatic semantics, a program establishes a relation, that is from data we can go to the results, or from the results we may be able to identify the initial data. This is basically a difference between denotational semantics and the axiomatic semantics. Now,
Sir, we were
hello.
not able to see your screen.
Yeah, from the data you can go to the results. If data is there, you can go to the results. This is number one. This is first one. But there may be some criteria is also there in the axiomatic semantics. From the results and the code is there, you can be able to find the initial data also. This is the things. Some are just go for the forward one. Some are both forward and backward, both are acceptable. That means backward reasoning may be there. That means from the results, you can find the initial data. And this is the difference between these two types of semantics.
Sir, are you sharing the screen?
Oh, sorry, I have forgotten to sharing the screen. Sorry. Just quickly go through these things, what I have discussed. I think it is visible now.
Yes, sir.
Yeah. Just quickly go through these things. Syntax, semantics, grammars, and axiomatic semantics. Syntax, there is form and meaning of the programming language, types of processing, and the types of language. What is syntax? Syntax is of a language determines how programs are built from the elementary units. That is keywords, identifier, numbers, brackets, and so on. And a syntactically correct program may still not be acceptable, or it may work in a way which is not acceptable by ourselves. This is the things. Got it? Just see. Formal syntax is a system for describing the structure of the program exactly, and such systems include the grammars, Backus noun form, syntactic diagrams, syntax graphs, which I will discuss when you will see this concept, when you will see the syntax diagram or syntax analysis phase of the compiler. Now, what is a grammar? Just see, there are infinitely many defined programs, but every program is finite and must be recognized in finite time. And a grammar should allow the finite description of any usually infinite language. That means if a grammar is not there in the language, you cannot be able to find the strings or pattern generated by the languages. That means what type of sentence can be generated by the language if you cannot say if the grammar is not properly defined for that particular language. Now, what is semantics? Semantics of the language determines the meaning of the elementary units and their combination. That means every elementary units or every production rules or every syntax rules must have a associated meaning of these things. Must have a associated meaning of these things. Suppose I am telling you your production rule is like these things. That means your ID produces ID plus ID. What is the meaning of these things? It is syntactically correct, maybe there, but ID produces ID plus ID means, that means value of the ID, second ID, that means you can say ID produces ID plus ID, that means two identifier value will be added and the result will be assigned to the initial ID. This is the thing. That means A assigns to B plus C. That is B plus C's value will be added and it will be assigned to the location of the variable of A. These are the things. And this is basically known as the semantics. That means every rule must have some interpretation or must have some routines associated with these things. And this is basically known as the semantics. For example, loop. Loop has some defined meaning compared to the control statement, that is if. These are the things. Got it? Now, methods of semantic description. Operational semantics, denotational semantics, and axiomatic semantics. Out of which operational semantics is very easy. Simple lower level operations explain how higher level statements are performed. Denotational semantics, a program computes a functions, that is a mapping from data to the results. And axiomatic semantics are the program establishes a relation. That means from the data you can reach to the results, and from the results you can reach to data also. These are the things. Now, lexical analysis, we have seen this concept. Syntactic analysis also I've seen, I'm not discussing. Yeah. What is a language? Now, a language is a set of sentences. And what is a sentence? A sentence is a sequence of elementary pieces built according to certain rules. And what are the rules? Usually the grammar rules. In a natural language, sentence must have their usual meaning, and the programming language, various syntactic unit can be considered as sentences. For example, in a set of all expressions, each valid expression is a sentence. In a set of all programs, each valid complete program is a sentence, and so on. These are the things. Is it understandable?
Yes, sir.
Formal language are classified on their complexity. We have seen as per the Chomsky hierarchy, that means regular, context-free, context-sensitive, and recursively enumerable language. And these are the types of the grammars also. As the language can be defined in this way, their corresponding grammars also defined in this way. Mainly, here we will deal with two things, that is context-free syntax and the context-sensitive semantics. Context-freeness, that means it is very important in the syntactic analysis phase, means that a fragment we are analyzing does not depend on any other fragment of the program. This is the meaning. Fragment we are analyzing does not depend on the fragment of any other fragment of the program. That is, occurrence of a variable is not related to its declaration. Occurrence of a variable is not related to its declaration. A message to a method is analyzed separately of the definition of this method. Now, formal grammar. Let's see. We have seen this concept, or you have seen this concept. Formal grammar has four components. Every grammar: terminal symbols, non-terminal symbols, the goal, that is the start symbol, and the production, that means rules. Terminal symbols, language elements like variable names in Java or English words like these things. Non-terminals one, auxiliary symbols denoting classes of the constructions. For example, loop statement, Boolean expressions. This is the non-terminal symbols. The goal or the start symbol denotes any sentence. Next one, productions, that is rewriting rules. The structure has such and such components like these things. Various types of production rules. A produces B plus C, like this. ID produces these things. Various types of production rules we will see. Now, two ways of rewriting using your production rules. From the start symbol, that means what we will see. From the start symbol, we will go to the sentences. That means we'll see whether a particular sentence is recognized by this language or not. This is number one. That is, from the start symbol, produce one or more specific approximation of the sentence and replacing the non-terminals with their definitions, and finally we reach somewhere. This is basically your top-down approach. And another one is that reduce the sentence into one or more general forms, replacing the definitions with the non-terminals, and reach the goal symbols or the start symbols. This is basically bottom-up approach. Produce, reduce. Producing means from the initial symbols you can reach to your sentences, and from the reduce means from the sentences you will start to reach to your start symbols. And productions are which makes a grammar regular, context free, or the context sensitive. Just see grammar of an expression. Here the terminal symbols are plus, minus, star, opening braces, closing braces, and two variables x and y. Non-terminal symbols are the expression, term, factor, and the variables. Let's see what is the meaning of these things. Start symbol your expression, and This is basically left hand side produces right hand side. Okay, let's see with an example. Yeah, this is the production of the grammars. You just see. Expression produces term, or expression may produces expression plus term, or expression minus term. Term produces factor, or term produces term into factor. Factor produces variable or expression, and variable produces x or y. Variable produces x or y. This is the productions and sample productions of the grammars. Now we just see top-down approach and bottom-up approach. Let us see example. Just we will take the sequence of the terminal symbols. We have to reach here from the start symbol x minus y in bracket star x plus y. Just how can I reach these things? Let us see. We just see here. It clearly, it's not very difficult, whether you are understanding or not. Expression, expression is your start symbol. From the expression we are producing expression plus term. Now expression, next one, this expression has been replaced by the term because there is a, you just see in the production rule, there is a term is there. Now term plus term. Now term may produce factor, that is term may produce term into factor. You just see, oh sorry, term may produce term into factor. That means this must be there. Let us show you. It's better you just see this production, you just note it down. Note down this production so that later on you can understand these things. Note down these productions. Is it okay? Should I proceed to the examples?
Please wait a minute, sir. A minute, sir.
Hmm.
Sir, in the factor part,
Hmm?
what does that bracket means?
Factor produces variable. Variable is an identifier, or factor may produces the expression in parentheses, enclosed in parentheses. Okay. Should I go to the example? Otherwise, we will not understand this thing. And now we will see, this is basically from the starting symbol, starting from your EXPR, expression is your start symbol. We will try to reach this sentence, that is x minus 1 in parenthesis into x plus y. Now see, starting from the expression, what are you getting? Expression, you just see expression produces expression plus term. This is step 1. Now you just see term also produces. Now expression also produces term. That means you just see expression first produces expression plus term. Now this expression has been produced with the term. Now you just see the production rules. Now as per the term, you just see term produces term into factor plus term as per the production rules. Now you just see term also produces factor. That means this term has been replaced by the factor. That means whatever reaching factor into factor plus term. Now you just see factor produces expression in the parenthesis. Factor produces expression into parenthesis, into factor plus term. And you just remember, replacement will be done only one at a time. That means for each of the expressions, each of the iterations, replacement will done. That means left hand side will be replaced by the right hand side symbols or the whatever may be these things once at a time. Not two expressions can be replaced or two variables can be replaced. This is not supported. Okay. Now, next one. You just see now EXPR, as per we know that what is that? Our expression is x minus y. That is the thing. That is why EXPR, basically EXPR has been replaced by EXPR minus term into factor plus term. Now EXPR has been replaced by the term. Now term will be replaced by the factor, and this is also term. Another term will be replaced by the factor. Yeah. Now factor has been replaced by the variables. Now variables can be replaced by x. And now this term again will be replaced by the factor, and the factor will be replaced by the variable, and the variable will be replaced by y. In this way, we are reaching this thing step by step. See this. And this is the top-down derivation. Starting from the expression, we are reaching our final sentences. Is it clear? Not difficult if you use the production rules properly. Just see these things and ask me if you have any doubts. Is it okay? Is this understandable?
Yes, sir.
This is the top-down one. And you just see bottom-up one. Starting from the sentences, we will reach to your start symbol. Let's see side by side how this comparison has been done. Just reverse of the top-down approaches. Right hand side will be replaced by the left hand side here from the bottom up, and the top down, every left hand side will be replaced by the right hand side of the production rules. Okay. Now, it seems to be easy. If you know you can use the production rules properly and use the replacement. That means one by one for each step, one replacement will be there. It's easy. But is it really so easy actually for implementing these things? Both the derivations, guessing is required. Which production should we use the next time? And strategies of choice are at the heart of the parsing algorithms. Ideally, we would always guess correctly, and less ideally, we may have to try a production, fail, and return to try another in this way. That means what I'm telling you, if you don't be able to use the productions properly, you may not reach to your destination, proper destination. Now, next one is the parse tree. This is the part of the syntax analyzer. You just quickly see these things, how you are reaching here. That means as per your production rules, that is this one, I'm talking about the top-down approaches. You just see from the expression, we are reaching expression plus term. From this statement, we are reaching term plus term. From this statement, we are reaching in this way, and this is the reflected in the production rules. This is reflected in the parse tree. You just see. Past expression, from expression you are reaching expression plus term. Now expression has been replaced by term. Term has been replaced by the factor, like these things. Term has been replaced by term into factor. Now term has been replaced by the factor. Factor has been replaced by the EXPR. In this way we are reaching, and this is your leaf nodes, which are always the terminal symbols or the variables. This is basically parse tree or abstract syntax tree. Is it okay? Are you understanding this parse tree? Hello?
Yes.
Just everybody tell me whether you are understanding the parse tree or not. Debarati Saha. দেবারতী সাহা পার্সটি বয়ে যাচ্ছে?
হ্যাঁ স্যার বোঝা যাচ্ছে।
শক্ত কিছু লাগছে না, তাই তো?
না এটা আসলে এটাও করেছিলাম থিওরি অফ কম্পিউটেশন পার্সটি।
Okay. This is parse tree. And if the parse tree, actually your sentence is the expression, numeric expression like these things, then you can say this parse tree as the expression tree also. Otherwise it is parse tree or abstract syntax tree. Now, okay, this portion I will discuss in the next day. Ambiguity like these things with the help of that. In the next day I will start from the syntax diagram, syntax analysis. Isa Paja, are you there? I think she is not.
No, sir, she is not.
Okay. Rahul, you just remember me. I will send what I discussed till now. I'll send you the slides. But if I forgot to send you before the next class, you just inform me. Okay.
Okay, sir.
Okay. And send me the attendance. Okay. See you in the next class.
Thank you, sir.
Thank you, sir.
Thank you, sir.